Today's problem was submitted by a viewer, and it says, show that for any natural number n, the fraction given by this expression can be reduced by 13. That is, both the numerator and denominator are divisible by 13. Okay, let me write this, write these two expressions out. Okay. So we need to show that the numerator and denominator are divisible by 13. How do you show something is divisible by 13? We can check if n is equal to 1. Why don't we start with n is equal to 0? The numerator is 5 plus 4 Did I copy this correctly? Oh, no, that should be a 3. So it's 5 plus 8. And here we have 4 plus 9, and that's 13 over 13. Let's try with n is equal to 1. The numerator, 5 cubed, 125, plus 32 times 3. Denominator is 8 plus 27 times 5. 125 plus 32 times 3, 98. (27 times 5). That's 25 times 5 plus 10, 135. (223) and 143. Are these both divisible by 13? Hold on. Did I do something? When n is equal to 1, I have 5 times 5 times 5 is 125. I have 2 to the power 5 is 32. Oh my goodness, 96. So this is 221. Which is divisible by 13, and 143 is divisible by 13. Okay. You know, I noticed that maybe I can, obviously 5 times 2 plus 3 is 13. So maybe there's a way I can factor this with a 5 times 2 plus 3. And same with the denominator. You know, because I want to write these things as 13 times something. So for the numerator, 5 to the 2n plus 1 plus 2 to the 2n plus 3 plus 3 to the, times 3 to the n. And I want to write this as 5 times 2 plus 3 times something. But how can we the denominator might be a little bit more straightforward. Okay, what if I just expand 2 times 5 plus 3 to the n? Maybe it's not supposed to be written to the power of n. Maybe I should write it squared. I have no idea. I mean, I just assume there's some kind of way of factoring these things in some way. What are these factors? This is 17 times 13 divided by 11 times 13. So I mean, how do you make these numbers 17 and 11 out of some convenient expressions of 2, 3, and 5? What if we go higher? I mean, we're getting into pretty large numbers here. I don't think I'm going to be able to spot a pattern. Why doesn't this work? Hold on. I've got n is equal to 2. 2 to the power 4, 16. 3 to the 4, 81. 5 squared, 25. 81 times 25. I don't see any pattern here. These are not divisible by 13, so I'm probably should not be raising to higher powers like this. Like what you're going to have to come up with a crazy expression to put here. Something that depends on n, involving 2 and 5 and 3, you know, I don't know. I don't know. There's going to be a way of factoring these two things that has this. I mean, maybe you look at a more general expression like x to the 2n plus 1 plus z to 2n plus 3, or y to 2n plus 3 plus times z to the 3. Z to the n, sorry. But and write this as xy plus z times something. I don't know. I'm not gonna think about this one too much more. It just seems to you're gonna have to pull some kind of factorization out of the air, and I don't see it. I don't want to spend more time on this one.